Hello, all. We thank God for granting us the opportunity to go through this lecture. As we start, let's have a short prayer. Heavenly Father, we thank you this evening for the gift of life, the strength, and knowledge you've given us to be alive today, to be able to go through this lecture. We pray that you will guide us through, and your name will be glorified at the end. In Jesus' name we pray. Amen. Thank you very much. All right, you're welcome. My name is Gideon Quality, and by God's grace, I'll be taking you through this course CAD-CAM. What we're doing now is to um, have some introduction to CAD-CAM. So let's consider this overview. CAD-CAM is a term which means computer-aided design and computer-aided manufacturing, and it is technology concerned with the use of digital computers to perform certain functions in design and production. So, as mentioned earlier, CAD/CAM is combination of two different terms, the CAD and CAM. Alright, so CAD, which is computer aided design, is defined as the use of computer systems to assist in the creation, modification, analysis, or optimization of a design. Alright, so here we have the computer which assists in doing that, and that computer system comprises the input system, that is your mouse, your keyboard that you use, and there should be, of course, a software which you will use for your design. Then the hardware aspect is there, which is your mouse, your keyboard, and then the computer system itself, which comprises your monitor, your system unit, and other components. Right, so that is about CAD, and you need to have all these things in proper working position for you to be able to um, have your system, your CAD system work correctly. So for instance, you have your computer, which is made up of your display unit, the monitor, and then your system unit or the CPU. And you should have a software installed on it which will assist you to produce the parts that you want to produce. Alright, and the CAD system makes it easier for you, the engineer, to be able to make whichever part that you want to make. Then we also have the CAM, which is a computer aided manufacturing, and it's defined as the use of computer systems to plan, to manage, and control the operations of manufacturing plant through either direct or indirect computer interface with the plant production resources, right? And these uh, can be categorized into two. The first one is the computer monitoring and control. And the computer monitoring and control um, are the it involves the direct applications in which the computer is connected directly to the manufacturing process for the purpose of monitoring or controlling the process. So there's a manufacturing process going on, and for it to be done, we connect the computer to the whole manufacturing process. Could be the plant. All right, so you have the manufacturing plant. Maybe you're working with a CNC machine, the computer numeric control machine. You want to manufacture a particular part, and instead of you to do it manually as using the manual machines or machines that instead of using the manual machine to produce the part whereby human being have to be there and directly control the machine. Here the computer is used to control that machine. So whichever activity that you want to be done on the machine, the computer will give all the commands to the machine and is able to produce the part that you want to produce. All right, so we have the computer which monitors and control the whole manufacturing process. Then we also have the manufacturing support applications, and these are the indirect applications in which the computer is used to support the production operations in the plant, but there is no direct interface between the computer and the manufacturing process. There is no direct interface, but there are certain things that maybe you want to do, but which will assist in the operation. And in that case, these computer support applications will be there to assist. So we categorize this come into these two. All right. Then let's look at the product life cycle. In the traditional environment, to produce a part, first we need to have a need. All right. So let's look at this diagram here, which gives us a flow chart of the life cycle of a product. So there has to be a need. So for instance, there is a need that we want to produce this particular, not produce this particular part per se, but there is a need that this is a problem. We want to achieve this. Let's say that we want to um, have, we need a way of assisting those who are disabled. We want to assist them in working, especially those who are crippled or could not work. So that is a problem there, that somebody needs supportive assistance or something to support him or her in working. Now that is a need. We have been able to forecast that this is the need. How do we solve it? First, it has to go through some cycle before we'll be able to solve that problem. And that cycle is we are trying to produce a part or trying to produce something, a product, come up with a product that will be able to solve that problem. And usually we need to have a concept, all right? So we need to have a conceptual idea of that product that we want, or a conceptual idea of how we want the product to look like. All right, so first the engineer or the person who is to produce, you the designer, the engineer, we need to conceptualize it within. So you think about it and imagine how you'll be able to produce that part or that component or that machine that will be able to assist somebody to work. All right, so that gives you that gives us the conceptual idea of it. So you have the concept of the product, but that concept you are having is in your mind. Nobody knows about it, and it's there. You may describe it, talk to people about it, how it looks like, but it's only maybe those people who are within your environment who will understand what you are trying to say. But even that one, it will be difficult for them to get the concept you are trying to describe. So what you will have to do for people to appreciate is to design the product. Designing of the product here includes the drawing of the product, drawing of the concept that you have. So you put it in a pictorial form where people will look at it and understand that, oh, this is what you meant or this is what you want to do. All right, so you will have to do that. Then after that, you have to uh, do what you call preparing part prints. So when you have done that, thing, that design of your thing, it has to be uh, printed out, or maybe if you have drafted it using pencil and ruler and those your instruments, that draft, you may have to have different copies of it. All right. Then from there, we come to process planning. So from this part printing, preparing part print now, we come to process planning. And the process planning here, we're not going to plan the the way that the part is going to be produced, or that product is going to be produced. Then from there, the order of tooling will have to come in. As you are planning the process, right, you need to consider the order of tooling, the tools that will be used to produce the part or the product. Then the order of material, and then the machines that you are going to use to produce that part, you have to consider them. And then the material that will be used, you have to consider them. Then the tool try out, all right, you need to try and see that it's going to work correctly as you uh, want it to work. Then we also have from the process planning again, we'll come to the scheduling manufacturing operations. You need to schedule the manufacturing operations. All right, so we need to make sure that, well, we are going to finish this work within this period of time, and it is this component will have to be produced first, or this portion of the component have to be produced first before this portion, before the other portion, in that order. Then establishing work standards, right? And the product that you are producing should conform to existing standards. All right, then everything will come to the actual product. All right, so when you have gone through, you have done the process planning, and everything is perfect, then the actual product is produced. And when that is done, we have to check if it conforms to standard, all right, conforms to the standard or conforms to the expectation. So do what we call the quality control. Then after that, the product goes to the market, right? So it goes to the market, you sell to customers, and when customers receive the product and they use it, they need to give feedback to the producer, and that feedback is going to help in um, the making the product better. All right. So when the feedback comes, or as the manufacturer or the designer, you receive feedback from the manufacturers, that will inform you on how your next product should be like. If you are going to improve it, what are um, the expectation of your customers, or what are the comments that they are giving on the product, and then with that information, with the comment that they are giving and the suggestion that they are giving, you improve on the concept. Then we go through the whole process again. All right, so we have this in two different brackets. The one is the design phase, where that one talks about the concept design and then the concept development and everything there. Then after that, we go to the production, or uh, the manufacturing or the production of the actual product that we want to market. All right, the actual product that we want to market. And then the traditional form, all these processes are done in the manual way. Manual way, which means that human beings, the designers, the engineer who is working on it, and all the people that are working on it have to be there physically, and have to go through all the processes manually to be able to achieve, or to be able to produce that part. All right, then that is of course very tedious and time consuming, and it's also costly. Let's put it that way too. Then we also have the uh, modern way of product or developing a product, and this one is a computerized form where most of the things that we have spoken about in the traditional form of product development um, here, or the product life cycle here, is done in the computer environment. The computer assists in doing that. Though we still have the human component there, but the computer helps in doing most of the things over here. All right, so here we have the everything fall within the bracket of CIM, which is the computer integrated manufacturing. All right, so again, over here, before the product is developed, again, we need to have the need. So first of all, there is a need. What is the need? This is the need in the market. This is the particular need, and we need to do something about it. So we have to come up with a concept. So we have a product concept of the component or the actual product we want to produce to be able to serve uh, that need. All right. So from there, we again go to the area where we have to do design. But in this case, it's a bit different from the previous one. Here, instead of doing the design manually by drafting on maybe with a board and a paper and all that, we use the computer aided design tools to assist us in doing it, and that improves our speed in the work. Of course, there are many things that we can do in this environment which will assist the product to be better than the previous one. Right, so here we have the computer aided design. The computer aided design, we are going to produce or design the concept which we have in our mind. We draw it with a computer, and in that we have what we call the geometric modeling. Geometric modeling is going to assist us as we model the geometry of the product. Right, and then we also have what we call finite element analysis, which is also can be done in with the computer aided design. In that case, you may want to find out the strength of the part that you have produced or the product that you are producing. You may want to find out, you want to find out the stresses, and then maybe do some fatigue analysis on it to determine whether it will be able to perform as required. Right, so here you can do all those things in the virtual environment, which you may not be able, you can't do when you are doing it in the manual way, but the computer can assist you to do all that. So before you even go to manufacturing the product, you have already tested to know the weak points on the material. You have optimized it to make sure that it will be able to function correctly without any problem. Then we can also do some simulation on it. Right, you can do simulation in the product, and it's still in the computer aided design environment. You can do simulation, for instance, if you are manufacturing a machine, right? You are making a whole complex machine, and this is made up of different parts. You can simulate it, and you're able to, with that you're able to know the interaction between the various parts. All right, so when we have done it and you have assembled it, you can simulate, you can do the simulation, and you'll be able to know the interaction between the various parts and all that that is done. Right, and that helps you to understand how it's really going to work or operate when it's produced. Then you also, you can do the drafting. So here is where you do you can do the where you do detailed drawings of the part, because before it's produced you have to detail it, put dimensions on it, and then you indicate the materials that are used for various parts and all that. Then you can have the various views of the various components of that product, and then it's printed out, all right, which will help or assist the manufacturer, the one who is to produce it. All right, then from there we move to, from the computer aided design we move to into the CAM environment. So after we have done the designing and everything, we come to the CAM where we are going to manufacture, computer aided manufacturing. Alright, so here we have computer aided process planning. So we do similar planning here, but not as the previous one where we have to do everything manually. Here we do it here, but with the aid of the computer. And then from there, we have the to order new equipment. All right, there is the need to, and there are certain equipment that you need to put in place which you don't have, and because of the complex nature of the parts you want to manufacture, you may have to get some other things on board, and then for the parts or the equipment to be arranged in a way that it should be. Then from there we have the computer aided tool design. Alright, so we need to design the tool, and then the tool manufacture manufacturing, and then try out. So you need to have the tool, everything, because if the part you are producing is complex part, you may have to use different tools for different shapes on the part as you define the geometry of the part. So there are times where you will have to design the tool, or you have to shape the tool to um, be able to match the work that is going to be used for, and that is also done in the CAM environment. So from this computer aided process planning, move to the material requirement planning. To the material that is going to be used, you still use the machine, the computer to help in that area. Then we also have computer aided CNC part programming generation. Right, so here if you are going to use a machine, a computer controlled machine to produce the part, and because of that you have to generate some codes, right? And there are times where you will have to generate type those codes yourself. That is, you have to do the coding yourself by looking at the parts, and then you have to define the tool part and everything yourself. Then there are times to, in the modern softwares that we have now, CAD softwares that we have, you can easily draw your parts that you want to produce. Then with the help of the software you can also generate the tool parts, which will be the codes. All right, so the CNC codes, which is the code that you have to generate, the computer will help you to generate those codes which will feed to the CNC machine to produce the part. Then still from there, from the computer aided process planning, we come to computer uh, aided scheduling. So here you also have to do scheduling here as before, but with the help of the computer. And we also have the computer aided work standard, similar to before, but here it's aided by the computer. Then we also use the computer aided scheduling to assist in the CNC, all right, machines in manufacturing the part. All right, then from there certainly we have robots and other material handling equipment. So we have maybe robots arms available, which will help in moving the parts we are making from one point to the other. Maybe you have to produce that part on different sets of machines. That robot assistance or material handling equipment will handle the part from one side, one machine to the other until the final part is produced. So everything comes to the actual product that we want to produce. Then from there, we have to do quality control. There have to be inspection, which is also aided by the computer. Then the product goes to the market. Then when it comes to the market here, customers will use it and they have to give feedback to the product designer. All right, so when the feedback comes in, then it will inform on how the next product should be like, whether we should modify it, should make it better, and the suggestions that will be given by the customers, the feedback that we receive, we can implement and see how we can make the product better. Then we repeat the whole procedure again. All right, now let's look have a brief have a brief look at CAD, AutoCAD. All right, so we're going to look at fundamentals of uh, CAD, fundamentals of CAD systems. As defined in the previous chapter, computer-aided design involves any type of design activity which makes use of the computer to develop, to analyze, or modify an engineering design. The user in the computer, um, um, modern CAD systems, also called the CAD/CAM systems, are based on interactive computer graphics, which is the ICG, interactive computer graphics. All right, and this one is mainly a computer system where we have a display unit, and that display unit is able to assist the designer who is making the part or designing or drawing the part, and is able to see it, and is interactive, and is able to relate well with it, understand the work that it's doing, and it's not like something that is done in the dark. So that interactive interface is there, the interactive computer graphics system. And the user in the computer graphics design system is the designer. All right, so the one who is working with the computer is the designer, and the designer usually is somebody who is trained or is skilled. He knows how to use the software, manipulate the software, use the computer very well to be able to do the design. All right, so that designer communicates data and command to the computer through any of several input devices. The computer communicates with the user through the screen. So as you put in the commands, the information, the software through using your input devices and all that, you get the feedback by the through the screen, by the display that you see on the screen. The designer creates an image on the screen by entering commands to call the desired software subroutines stored in the computer. In most systems, the image is constructed out of basic geometric element points, lines, circles, and so on. So that is what you see. So you have systems like AutoCAD, SolidWorks, Inventor, IronCAD, and many other CAD systems. All of them operate on the same basic principles. So first, you may have to start by producing a geometry, right, from a point, from lines, from circles, and many other things, and you're able to have complex geometries. All right. It is important to note the fact that The interactive unit is one component of computer aided design system. All right. So that interactive computer graphics is one component. The software is one component. The other major component is the human designer. And as I mentioned, there should be a human designer who is skilled, like you, like as we are going through now. That is to equip you with the necessary skills to be able to use the softwares like that. Interactive computer graphics is a tool used by the designer to solve the design problem. In effect, the interactive computer graphics system magnifies the powers of the designer. So when you do it, it magnifies your powers. It helps you to bring out that creative thing that you have within your mind. This has been referred to as the synergistic effect, and it means that the designer performs the portion of the design process that is most suitable to human intellectual skills, that is to conceptualize it and to have independent thinking is a human element. That's that. A computer performs the task best suited to its capabilities, which is speed of calculations, visual display, storage of large data, and all that. The computer will do that. The resulting system exceeds the sum of its components. Alright, so that is if the computer is to work alone and the human being is to work alone separately and you put them together, the achievements that the computer and the human beings will obtain when they are working together will be more than when they are working separately. Of course, they will not be able to have a very good um, output compared to when the human being and the computer work together. Today's CAD technology can provide the engineer or the designer the necessary help in the following ways. There are many benefits to um, with the use of CAD in design. CAD is faster, right? That is faster and more accurate than conventional methods. It's very fast. For instance, if you want to draw a triangle and you're using CAD to do it, be very fast compared to when you are using your hand with a board and a paper and a pencil with eraser and all that. That's very difficult. You want to clear or clean some line, rub a line in the computer aided design, it will do it very clean without leaving any trace. All right, you print on the paper, you have a very clean work. But if you are doing the same with the pencil and the paper, you may end up having a dirty work. All right, but computer aided design, that it, it's very accurate. So if you are drawing a line of say 100 millimeters, you get 100 millimeters. If you're using your ruler and you have to measure 100 millimeters, and you have to approximate, you may not get exact on the ruler because in the markings on it where you will put, you want to measure and you put your ruler on the paper, a starting point and then the ending point, you may end up not getting the actual point where the 100 millimeter is because maybe you are not watching clearly on it. You may have to approximate to have whatever line that you are drawing. But in the CAD environment, you have the exact that you want. The various construction facilities available in CAD will make the job of developing the model and associated drafting a very easy task. It makes it less stressful and easy if you are using the CAD compared to the traditional method. In contrast with the traditional drawing method, under CAD, it is possible to manipulate various dimensions, attributes, and distances of the drawing elements. This quality makes CAD useful for design work. Right, so it's easy to manipulate, to change the shape, to decrease dimension, increase dimension. It's very easy to do those manipulations on the card than the traditional method. Under card, you will never have to repeat the design or drawing of your component. You will never have to repeat the design or drawing of your components. If you draw once, you can copy and replicate it. All right, you can duplicate many of them, several of them. All right, so if you have drawn a square here, you want a square at the other side, you can just copy it and then you have it there. You can do mirroring, you can rotate to whichever angle that you want in the card environment. If you want to do the same thing manually, it's not possible, and it will take you several minutes or hours to be able to do another one. But in the card environment, you can just copy and transfer to whichever place that you want it to be. And a card, you will never have to repeat the design or drawing of any component. All right, so that one has to be noted. Then you can accurately calculate the various geometric properties, including dimensions of various components interactively in CAD without actually making the models or the profiles. You can accurately calculate the various geometric properties, including the dimensions of various components interactively in CAD. You can easily do that with the constraint-based modeling method that are prevalent in most of the commercially available CAD systems. It is possible to capture the design intent into the product model beyond the simple geometry. So here this makes modification easily. It makes it very easy. And what happens here is that in CAD, in some of the CAD systems, um, you can constrain your drawing such that the various aspects of that geometry they are connected or they are related. So for instance, if you have a triangle, or let's say a rectangle, all right, and you have drawn the rectangle with a height of say 50 millimeters and then a length of say 70 millimeters, and you want to enlarge it. All right, let's say you have been able to do that and you want to enlarge it. You see that if you want to enlarge that rectangle and you want to increase say the length to be, instead of 70 you want it to be 80, and then the height, instead of say 50 you want it to be 60, you can do that easily. You can just change the dimensions to enlarge it. All right, and then if you have converted this rectangle, let's say you have drawn something like let's say a cuboid, all right, or a cube. You have drawn something like a cube from it. So that rectangular box which you have drawn, let's say that you have extruded the rectangle, you have that rectangular box, and then you want to change the dimensions. Right, another circumstance, if you have done on the manual way, you have to clean everything and start afresh. But here, let's say you want to change just the rectangular base or the dimensions of the base, you can easily change the dimensions of the base and it will take effect in the final product. So they are somehow constrained that if one member is affected, or you change the dimensions of one member, it affects the other ones too, and it makes modification easy. So even when you have done so much into your drawing, and realize that, oh, I should have, this dimension should have been smaller than what I've used, or should have been bigger than what I've used, you can just go back, change it, and it will affect the others very quickly, and then you continue. All right, then use of standard components makes for a very fast model development work. All right, there are some components which are there and they are standards. We have the part libraries and some of the cards, um, commercial cards that are available, and those libraries, the parts which are common, they are there. So for instance, let's say you want a part like bolt and nuts. Bolt and nuts, it says they are standard ones which are, you can easily, you don't have to start and draw it from the beginning and go through various processes to be able to produce it. No, they are there. You can just pick it from the libraries, put the dimension that you want for it, and there you go. You have the boot and that. You put it on the drawing wherever that you want to put it, and that makes things very easy and fast. All right. Professional card packages provide 3D um, visualization capabilities so that the designer can see the products being designed from several different orientations. So here, like you have the 3D object in the virtual environment, you can rotate it, turn it around several degrees, I mean all around. And because in three-dimensional in CAD environments has about 6 degrees of freedom, so you can rotate, you can move it, all right, translate it in this direction, in that direction, in the vertical direction, and then you can rotate it in all three axes, x, y, z. All right, so you can see different views of it, unlike when you are using the traditional way of drawing with your paper. All right, if you want to see another view, you have to start all over and draw another one. But if you are working with the 3D um, in the CAD environment, it's very easy to look at the object from different directions, and you see as you develop the product. Several designers can work simultaneously on the same product and can gradually build the product in the modular fashion. So on the same product, you can have several designers working on it. Right? You can work simultaneously the same at the same time. Especially well in this time we have cloud computing, or there are some which are in the cloud where many people can connect from different places, and there are some card system where they have the vault uh, designing um, capabilities where different designers can just link up through a network, then they can all work on the same product and they can quickly work on it to produce the part that they want. All right. The application of computers for design. The various design related tasks which are performed by a modern computer aided design system can be grouped into um, these four functional areas. We have the geometric modeling, we have the engineering analysis, design review and evaluation, and automated drafting. Geometric modeling corresponds to the synthesis phase, in which the physical design project takes form on the ICG system. Alright, so interactive computer graphics system, you are using the software, and then you are the designer, you sit down, then you model the part, that is the geometric modeling, and In that case, you see the part and then you produce all the part that you want to produce. Then from there, we have the engineering analysis, which deals with the analysis and optimization of the design. So when you have done the design, I mentioned earlier, the part where you want to do maybe some analysis on like finite element analysis to determine the strength of the parts that you have produced. Right, so in that case, you may carry out some stress analysis on it or fatigue analysis, or you may look at other aspects of that design and you may optimize it. Maybe, for instance, you want to produce a bar which is going to be used to carry a load of, say, 50 kilograms, and let's say something like a beam. All right, that beam, or let's, if we take the automobile, let's take the axle of the automobile, and it is going to be supported at the ends, all right, by the wheels of the vehicle. So if we take the, let's say, the front axle supported at the ends by the wheels of the vehicle, and there is a load in the middle, let's say that is the weight of the engine or the weight of the vehicle at the middle of it. You want to determine, will it be able to carry that load? Will it bend? Will it fail? Will it break? What will happen to it when you have used it for a very long time? All right, where there's vibration and it's going through holes, potholes on the road and all that. So you may carry out that finite element analysis on it. You may carry out that fatigue analysis. Then with that, you'll be able to tell you that, oh, with this shape that you are having, with this design that you are having, when it goes through this particular cyclic loading for this number of times, is going to fail, and this is the point it's likely to fail at. Then you can modify that, or the assignment, you will know that, oh, I have over designed the part, it is too big. So if it is too big, I may have to optimize it by doing shape optimization, and all can be done by using um, the CAD, all right, the CAD system. All right, so that is the analysis part. Design review and evaluation involves a careful inspection of all parts of the design to ensure that it conforms to required expectation. So you have to look at that, make sure that it conforms to the required expectation. Automated drafting involves a procedure for converting the design image data residing in the computer memory into a hard copy document. All right, so that is where we print out that document. All right, thank you very much. We will end here for now. In the next one, we are going to look at some card system that is available, which we'll be using to practice how to use the computer aided design. Thank you. Have a nice time.